students, this is Janani. I am working as an assistant professor in SSMIT. Today we are going to discuss about binomial distribution.
Okay, let us discuss the topic binomial distribution. Binomial distribution. So from the term bi, everyone knows that bi means 2. Okay, so there are many real life situations. Here binomial distribution deals with the problems whose outcomes are of two categories. Here two categories in the sense we may tell it as success or failure. Otherwise we can tell it as true or false. Okay, so in simple way, the binomial distribution deals with the problem involves in such a way that the outcomes are of two categories, that is success and failure, otherwise true or false. Otherwise we can tell it as acceptable or defective, independent, non-independent, survey or died. So that is the output should be only of two categories. Okay, so next I'm going to tell you the requirements. What are all the requirements that a problem should come under binomial distributions? Okay, so what are all the requirements? Okay, the first one is the number of trials. Number of trials should be fixed. Okay, in case if we are tossing a coin, the number of times we are tossing a coin should be a fixed number. That is n times we can toss, that is 10 times or 15 times, like that we have to fix it. Okay, the second point is the trial must be independent. The trials, that is the happening of one trial should not affect the other one. Okay, the trial must be independent. The next one, third point, is the outcome of each trial. Outcome of each trial is classified into two categories. That is success or failure, otherwise true or false, like that. That is in each trial the outcome should be only classified into two categories, that is either success or failure, otherwise true or false, other some other things. Okay, the fourth one is the probability of success. The probability of success remains same. Probability of success remains same in all the trials. That is, if we are tossing a coin, the probability of getting head in one trial must be same as the probability of getting head in the another trial. It should not differ for each trial. Okay, the probability must remain same in all the trial. Okay, Okay, so I'll repeat once again. So now we have discussed the topic binomial distribution. The term bi means two. The binomial distribution deals with a problem whose outcomes are of two categories. That is, if a problem in which the outcome is of two categories, that is, if an outcome is either success or failure, otherwise true or false, we can think of a binomial distribution, whether this problem may lie in the binomial distribution likewise. Okay, then these are all the requirements. If we want to solve a problem in binomial distribution, these are all the requirements, things that we have to check before we are starting the problem. Okay, so first thing is the number of trials should be fixed. The second one is the trial must be independent. The third one is outcome of each trial is classified into two categories, that is, either it may be a success or failure, that otherwise true or false. The fourth point is the probability of success, it should be remain same in all the trials. Okay, next let us discuss the notations that we're going to apply. Notations that we're going to apply in binomial distributions. Okay, so here the small letter p denotes the probability of success. Okay, probability of success, and the small letter q denote the probability of failure. Okay, and then n, small letter n denote the number of trials. That is, number of trials is a number of times an event had happened, that is n. Okay, then capital letter X denote specific number of success in n trials. In tossing a coin 5 times, what is the probability of getting head 3 times? In that case, we can use binomial distribution. Okay, that is specific number of success. If you are tossing a coin 5 times, probability of getting success 3 times, that is, the 3 denotes the specific number. Okay, success in n trials. So here the success varies from, so since I am tossing a coin 5 times, I may get the success 0 times, 1 time, 2 time, 3 time, etc. up to 5 times. So and our success varies from 0 to n. So this is the important thing that we have to note it down. Okay, okay. Then here the small letter p denote the probability of success in one of n trial. Okay, similarly probability of failure is nothing but probability of failure in one of n trial. Okay, so these are all the basics notations that we are going to use in binomial distribution. Next I am going to tell you what is the actual formula that we are going to apply in binomial distribution. Okay, so formula. Okay, so formula, probability of x is equal to x, that is probability of getting success x times success equal to, the formula is NCX p power x q power n minus x. As I said earlier, x varies from 0, 1, 2, 3, etc. up to n. Okay, so just I will interrupt this formula. Okay, I will interrupt this formula. Here p plus q, the probability of success plus failure, it is equal to 1. Okay, I will interrupt this formula. Let us take an example. Tossing a dice 5 times. Tossing a dice 5 times. I need to find probability of getting 3 times. Just I need to get the 2 while tossing a dice 5 times. Okay, so just I going to toss a coin 5 times. So just I have draw a line, 5 different lines. Okay, so probability of getting 2 in tossing a dice is 1 by 6. Then Q, the probability of not getting 2 is 5 by 6. Okay, so if I need 2 3 times, so 1 by 6, 1 by 6, 1 by 6. Okay, so these are all the probability of getting 2. Okay, then the remaining position will be, I can get any of the remaining 5 numbers. So 5 by 6, 5 by 6. Okay. So this is we can compare these two things. Here 1 by 6 denotes the P. So it is nothing but P power x, and it is nothing but Q power n minus 6. Then the thing we have to notice, in the formula we are having in the formula we are having NCX. Okay, NCX. Here what does this NCX means? Okay, we have to I explain this. Since we are arranging, since we are tossing 5 different dice 5 times, so this is the probability distribution. This is P power x and this is Q power n minus x. Okay, so here NCX denotes that is the arranging these things in a different ways. That is I may have it as 1 by 6, 5 by 6, 1 by 6, 1 by 6, 5 by 6. So in how many ways I can arrange this? Can be written as 5cx. Okay, so n denotes the 5. Here x denotes, that is in the 1 by 6 can be arranged in these 5 different positions can be in NCX ways. Okay, so from this it denotes the number of arrangement, that is number of combinations. Okay, so from this concept I got this formula. Okay, then they have found the formula for a mean of the binomial distribution is nothing but NP. Similarly variance is nothing but NPQ. Since variance is NPQ, then the standard deviation will be square root of NPQ. Okay, now let us look at an example. With that example we can stop this video. Okay, so just I'll explain you with an example. A die is tossed 3 times. What is the probability? What is the probability of no 5 turning up? This again one is 1 5 turning up. Okay, so we're going to do this problem. Since a die is tossed 3 times, here n is 3. Okay, x denote the small letter x. Then here you can write the formula for P. P denote the probability of getting 5 in one trial. Probability of getting 5 in one trial. So it is nothing but 1 by 6. Similarly, then q will be 5 by 6. Okay. So the first one is the probability of no 5 is turning up, that is x should be 0, that is success. Since we are getting no 5s, so x will be 0. The formula will be probability of x is equal to 0. Before that, probability of x is equal to x is nothing but ncx p power x q power n minus x. For x is equal to 0, it represent that is 3c0, 1 by 6 power 0, 5 by 6 power 3. Okay, the answer will be 0.5787. By using calculator we can do that. Okay, then 1 5 is turning up, that is x is equal to 1. So I need to find the formula. Probability of x is equal to 1, it is nothing but 3c1, 1 by 6 and 5 by 6 power 2. So the answer will be 0.34722. Okay, so this is an example for a binomial distribution. Hope everyone understood. Okay, thank you.